Hi everyone and welcome back to Maths and Physics, Mr. Simons. Grade 12 Analytical Geometry. We're looking now at November 2015 exam question, grade 12. Right, so in the diagram below, Q, 5 and 2 is the center of the circle that intersect the y-axis at P, 0 and 6, and S. The tangent APB, so APB there's a tangent, intersects the x-axis at B. So that's the information given. Let's look at the questions. So 4.1, determine the equation of the circle. So they've given me the center is Q, 5 and 2, right? So we're going to substitute, because it's not 0 and 0, we have to substitute in x minus a squared plus y minus b squared equal r squared. Right, so we're going to substitute in this formula, right? And plus 5 must go in as negative 5 and plus 2 goes in as negative 2. Very important you remember, the signs always change. So there, Q5 and 2 becomes x minus 5 squared, y minus 2 squared equal r squared. Right? Now, from Q to P, I assume you know that's a radius. Right? So to get the length of the radius, I'm going to substitute 6 and 0. So P is 0 and 6, x equals 0 there, right? Y equals 6. So 0 minus 5 gives me 5 squared, which is 25. 6 minus 2 gives me 4 squared, which is 16, and 16 plus 25 would then give me 41. So r squared equals 41. So now my equation becomes x minus 5 squared plus y minus 2 squared equal 41. So this is one of the 3 ways we generally test you to find the equation of the circle. Right, so there's my equation. Right, and I hope you followed what I've done. You need to practice and get this into your head. Right, 4.2, now we want the coordinates of S. Calculate the coordinates of S. So as you can see, S falls on the circumference of the circle, so it's part of a point that we can get using the equation of the circle. So whenever we find the equation of the circle, we will test whether you can use this equation, right? So S there is on the y-axis, so therefore it's called a y-intercept. Y-intercept, x equal to 0. So S is a y-intercept, x equals 0. So that means there I'm going to substitute 0 in the place of x, and then I'm going to multiply out. Now listen very carefully to what I'm saying. If you forget the middle term here, the whole problem becomes wrong. Right? So, see there I have 0 minus 5 squared plus y minus 2 squared equal 41. Negative 5 times negative 5 would give me positive 25. Yeah, I'm going to say y times y to get y squared. Then I'm going to say y times negative 2 gives me negative 2y, and multiply it by 2 to get the middle term, which is negative 4y, and then negative 2 times negative 2 gives me positive 4. But I'm going to do it now again. So you see there, negative 5 times negative 5, 25. Y times y, y squared. Negative 2y in the bracket times 2 gives me negative 4y. Negative 2 times negative 2, positive 4. And you bring 41 across, it becomes negative 41. So if I simplify, I have y squared minus 4y. It gives me 29, so that should be negative 12. Right, so there I have y squared minus 4y minus 12 equals 0. If I factorize now, I'm going to use 6 and 2. No? 6 times 2 gives me 12, but 6 minus 2 would give me a 4. Right, so y minus 6, y plus 2, y times y squared. Minus 6y, the two closest, plus 2y from the two furthest. Minus 6y plus 2y gives me negative 4y. And there, negative 6 times positive 2, negative 12. So y equals 6 or y equals negative 2. Right? But S is below the x-axis, so x there, or the y value there should then be negative for S. So S is 0 and negative 2. Alright, so I hope you follow. Determine the equation of the tangent APB in the form y equal mx plus c. So we have here on the tangent, we have P 0 and 6, but we have no other point on the tangent, right? And we have Q 5 and 2, right? So you can go gradient of my radius using Q and P equal y2 minus y1, x2 minus x1. So there's 6 minus 2, 0 minus 5. Be very careful with how you substitute. No? So therefore 6 minus 2, 0 minus 5. So if I choose from there, the x value must be right underneath it. You see there, and 2 and 5. That gives me 4 over negative 5, 6 minus 2, 4 over negative 5. So that's the gradient of my radius. But remember, radius and a tangent always meets at 90 degrees. So that means the gradient of the radius times the gradient of the tangent must always equal minus 1. Right? So if they're minus 1, I can then say the gradient of the tangent here would be positive 5 over 4. Right? And my reason would be tan perpendicular to radius. So that times this must always give me minus 1. So we just flip the fraction and change the sign. So 4 over 5 became 5 over 4 and negative became positive, right? Now, my equation now reads, in place of m, y equal 5 over 4x plus c, right? But that straight line goes through the y-intercept 6, so I don't still need to calculate c. C would then equal 6 because that's a y-intercept. So my equation y equal 5 over 4x plus 6. Alright, so I hope you follow and you see what I've done. Now they want us to calculate the size of alpha. Right, so we just got that gradient there is 4 over 5 if you remember correctly. So I can say the tan of alpha using angle of inclination equal the gradient of APB. Alright, so gradient of APB 5 over 4. From here in my calculator, I'm going to press shift tan 5 over 4. No? Or second function tan 5 over 4. Or in old maths, we would say arctan 5 over 4. Alright, and that gives me alpha equal 51,34. So this angle here is 51,34. And I assume you can see here, if we just do this part, that's a 90-degree angle there. So technically you can find that angle there. Alright. So calculate with reasons the size of theta. So take note theta there. There in blue, I have my triangle. It's making contact with the circumference of the circle. You see S is on the circle, R and P, right? And then BPA is a tangent. So therefore, angle tan chord, this angle here must equal that angle there according to tan chord theorem. Right? So if that's theta, that there is theta. So therefore, I can say SPB equal theta tan chord. So therefore that there is theta. Right now, I've got 90 degrees. I have that as 51,34 if I remember correctly. So 180 minus 90 minus 51,34 should give me alpha. So theta equal 180 minus 90 minus 51,34. And from there, theta then equal 38,66 degrees. So this is 38,66 and that there is 38,66. Right, from there, they want us to calculate the area of triangle PQS. So PQS, then baby blue. Right, sorry, my colors, I'll just call it baby blue. Others will say it's teal. Right, so that triangle there, so we know we have x minus 5 squared plus y minus 2 squared equal 41 for the whole circle. See, we have this angle here. We can go back to theorem 2 that states angle at center equal 2 times angle at circumference. Right, so then we get that angle. We know PQ is a radius and QS is a radius, so then I have two sides and an angle. So then from there I can use what they call the area rule, right? So PQ equal QS equals square root 41. They are radii. So that two are both a radius. Therefore they both square root 41. Angle PQS equal 38,66 times 2. Right? And gives me 77,32. Angle at center, you see the angle formed at center will always equal 2 times angle formed at circumference. That angle must make contact with the circle. Right? So PQS is 77,32 degrees. Now for area, I'm going to use the area rule. It says half PQ times QS times the sine of the angle in between the two sides. So sine PQS. So PQ square root 41, that gives me 41 times the sine of 77,32. Right, and if I multiply it all out, I would get the answer of 20 square units, or 20 units squared. Right, so that there concludes this exam question. I hope you understood. I hope you enjoyed the lesson, and I wish you nothing but the best as you practice to get better. God bless. Bye.